This is a crossover question from Edexcel Paper 1, November 2024. This was question 21 on the foundation paper and question 4 on the higher paper. ABCD is a parallelogram, so this is important. We'll come back to this in a minute. Find an expression in terms of E, so we need an expression in terms of E for the size of angle CAD. So CAD is CAD, so this angle over here. We're told in the question that the shape is a parallelogram. What this tells us immediately is that this side AB is parallel to this side DC, and that this side AD is parallel to this side BC. This is because opposite sides in a parallelogram are parallel. So parallel lines are two or more straight lines traveling in the same direction, and the distance between them never changes. So because of this, the lines will never meet. Now, when we have two or more parallel lines and we cut through them with a transversal, so a transversal is a line that goes diagonal through the parallel lines. Now, when that happens, we get distinct types of angles, and one of these are called alternate angles. So alternate angles are zigzag angles. They are Z or N shaped. So you could have a Z going forward, backwards, N, or backwards N. Now if we look at a diagram here, if I travel from B to A, and then I go down to C and then D, you can see we've got alternate angles there. Right, so the rule with alternate angles is that they're equal. So if we look at a Z shape this way, the angle in this fold is equal to this angle here. And if we have one facing backwards, the angle in this fold is equal to this angle here. So what that tells us with our diagram, so if we look at the fold here, so we've got angle E, so this must be angle E as well. Right, so I'm going to label this angle here E, and then I'm going to make a note and say angle ACD. So when you're naming angles, the one we're referring to goes in the middle. So you've got AC and CD are forming the angle, right? So the one in the middle is C, so angle ACD is this one. So angle ACD equals E, and then you need to give the reason. And the reason, all you need to say here is alternate angles. So alt angles, yep, brackets. So ACD equals E, and the reason is alternate angles. So now that we know that this angle here is E, it's not difficult to find this angle. Now if we look at this, you can see that this is a triangle. So ACD is a triangle. So I'm going to make a note of that because we need to use this fact. So ACD is a triangle, right? So we're talking about the shape now. So this shape ACD is a triangle, right? So we're going to use the fact that angle in a triangle add up to 180. So what I'm going to do is I'm going to add this angle, and then I'm going to take it away from 180 to find the missing angle CAD. Right, so we're going to start by adding angle ACD, and then I'm going to add angle ADC. Right, so ACD is E, which is this one here, and I'm going to add angle ADC, which is this one here. So that's 3E. Yeah, so 3E, which is the same as 1E. So 1E plus 3E is 4E. So to find our missing angle, which is CAD, to find this angle here, I'm going to take 4E away from 180. So I'm going to make a note here and say angle CAD equal 180 degrees. Take away 4E. And this is our final answer. Right, the questions asked us for an expression, and there's a reason I've highlighted this. So here we've got two terms and they're linked by an operator. So this makes this an expression. Right, this question is worth 3 marks. The first mark is a method mark for finding angle E. The second mark is an accuracy mark for the correct expression of 180 take away 4E. And the last mark is a communication mark for stating alternate angles are equal.